When we want to oxidize an alcohol, we use a mixture of potassium dichromate, K2Cr2O7, and dilute sulfuric acid, H2SO4. It is the dichromate ion that is orange and which oxidizes the alcohol. So the formula of the dichromate ion, Cr2O7 2-, that's orange. Now, when we think about Cr2O7 2-, we can think about the oxidation number of chromium inside that ion. When the oxidation reaction occurs, the alcohol is oxidized, the chromium is going to be reduced, and we end up with chromium in the +3 oxidation state. Okay, so have a think about, and if necessary, pause the video. What is the oxidation number of chromium in Cr2O7 2-? Well, there are 7 oxygens, which is 14-. So the chromiums, 2 of them together need to add up to 12+, so each chromium must be in the +6 oxidation state. This is orange, this is green. Now it's quite complicated trying to write an equation with K2Cr2O7, so we're never going to actually use that formula in any equation. We're going to represent this oxidizing agent as O in a square bracket. This oxidizing agent is going to take a primary alcohol and turn a primary alcohol into an aldehyde. The functional group of an aldehyde can be written so, or it could be represented like this. Although this doesn't correctly show bonding order, it's written like this in order to differentiate it from an alcohol. The carboxylic acid has an extra oxygen. There's an extra oxidizing agent used in the formation of the carboxylic acid, or Cu. Now, in order to do this, the condition matters. To make an aldehyde, we need to use distillation. To make a carboxylic acid, we need to use a process called reflux. And the reflux means that the alcohol and the oxidizing agent are in contact with each other for longer, and so this extra oxygen can be introduced into the aldehyde structure. In terms of a general equation, an alcohol, R, can be any carbon chain. We're going to react it with an oxidizing agent. The oxidizing agent pulls 2 hydrogens out, makes water, and leaves behind the aldehyde. So pause the video, have a go at this question. Okay, so oxidation of propan 1-ol. We can do it skeletally, prop and 1-ol. That's going to interact with the oxidizing agent, and we're going to turn that into prop and al. Now, I could draw the hydrogen on there, but if I'm doing it skeletally, I don't need to. And of course, don't forget the water. Now, there's a benefit of doing it skeletally, it's faster, but we don't see all the hydrogens that are going to interact with the oxidizing agent to make the water. When we move on to oxidation of primary alcohols to make a carboxylic acid, if we've got RCH2OH, now, if I only use one oxidizing agent, I'm going to end up with my aldehyde. I need to use 2 oxidizing agents. And what will happen here is, rather than just forming an aldehyde, the extra oxygen now appears in the structure, the carboxylic acid. And we still make that original water molecule that we did, just like when we oxidized the primary alcohol to make the aldehyde. Pause the video, have a go at this equation. Okay, so propan 1-ol plus this time 2 oxidizing agents. Remember, we only make 1 water. The first oxidizing agent pulls hydrogens out of the alcohol structure. The second oxidizing agent inserts itself into the aldehyde structure, and we will make 3 carbons there, look, carbon-oxygen double bond and the OH group, or CH3, CH2, COOH. When we move on to oxidation of secondary alcohols, we're going to make a different functional group, a ketone. We can't oxidize a ketone any further, so there's only one thing we can make from our oxidation of a secondary alcohol, the ketone. The ketone functional group is a CO double bond sandwiched between 2 carbons. These 2 carbon branches do not need to be the same length. So when we think about a secondary alcohol, we can oxidize it. The oxidizing agent again pulls 2 hydrogens out to make water, and leaving behind that ketone structure. Excuse the spelling error. Propan 2-ol propan 2-ol will turn into this structure, prop and one, as in ketone. Going back to our original page, our propan 1-ol makes propan-al for an aldehyde and oic acids for carboxylic acids. So we've got aldehydes, carboxylic acids formed from primary alcohols, ketones from secondary alcohols. So name a functional group, aldehyde, ketone, carboxylic acid.